お時間となりましたので、こちら丸文株式会社ブースにおきましてセミナーを開催いたします。どうぞよろしくお願いいたします。
Good. Hello. Thank you. My name is Paul Scode, and today I'm going to be talking to you about timing and security and how we find that timing is directly related to security on networks, and I will show you some new technologies as to how that works. So with that, let's get started. Let's first talk about the time of day landscape. In this case, we're talking about accurate, reliable, and secure time that helps improve network operations and business operations. So if we walk through this, you can see that the number one area where we use timing in the network is log file timestamps. And in particular, this would be for system, event, and information monitoring systems, where it's very important that you have an accurate timestamp so that the data correlates properly and you get high integrity value from your reports. Another area in the network that's very common for accurate timing is for network security, and in particular, the Kerberos network. Now, Kerberos is used by Windows, okay, to authenticate clients and servers, and they use time and time accuracy between the client and the server to authenticate one another. If the time is off too far from the right time, the client is off, the client can't authenticate. So it's very important to have accurate time for that reason in the network. Then, of course, because we're humans, we like the right time. We like the right time on email and phone systems and so forth. And so it's another value add of a time server. But more importantly, in network operations, certainly in backup and archival, it's very important. But more and more, memcache timestamping is very important for keeping track of memory and virtual machines are using, and be able to release that memory and make it available for other applications at the right time. So now that we use the time in these areas, what I'd like to do is basically put it in context of accuracy, security, and reliability of the time on the network. These are the three main reasons why people put a dedicated time server on a network. Usually, one or two of these is most important. So let me walk through each one of these for you. I'm going to do it in the context of a new network time server called the Sync Server S600. It's basically it's a GPS referenced network time server, multi-port. Each port acts like its own time server, and then it's very easy to use. It has web GUI, web interface for it, can track multiple satellites, which is very useful for accurate time, but also if you're in an urban canyon environment with a limited sky view, having more constellations to track gives you more satellites to get the correct time. So let me talk about a few of the features here in the context of accuracy, security, and reliability. First, the clock itself. This is an extremely accurate clock in this device. It's accurate to 15 nanoseconds to UTC. That UTC is Universal Time Coordinated. All networks, every network in this building at its very core is being synchronized to UTC. Using the network time protocol is most common. Now, sometimes you will lose connection to the satellites. Maybe the antenna cable gets unplugged or lightning strikes the antenna. You still need the clock to be accurate. And so we define how accurate it is by something called the holdover. So if you disconnected GPS for 24 hours with a standard clock in there, it would still be accurate to 400 microseconds. But we sell an atomic clock that can go in there. It uses rubidium, and it's accurate to 1/millionth of a second, 1 microsecond, after 1 day, and even 3/millionths of a second after 3 days. And it's a very interesting technology. I have one right here in my hand. This is what a miniature atomic clock looks like. If you're interested, after the presentation I can show you how it works. It's very interesting. But nonetheless, it's a very important technology to keep the clock accurate. Then of course, another very important part of accuracy is how well you can timestamp the NTP packets. In this product, it only uses hardware timestamping. This is unique. No other time servers use hardware timestamping exclusively. It basically improves the time accuracy of the time on the network, and uses some interesting patented technology from microsemi. So, what I want to do is show you some of that technology, and it's very interesting because not only is it accurate, but it's security hardened and works like a firewall at the same time you serve time. So if we walk through this, you have the network, and this is the time server over here, some of the electronics. So inbound NTP packets come in, they go directly into the hardware, they're time-stamped, and they're returned. And we do this at line speed. We'll do this at a gigabit rate, and we can time-stamp 360,000 NTP requests per second. But the beauty of it is that any non-NTP traffic that comes in, it hits the reflector, and then it's dropped. And that completely protects the CPU. And that's what we want to do. We want to respond to packets that drop any kind of denial of service attack or someone trying to hack into the CPU. So it works like a firewall, but responds to the NTP packets. So there's several advantages to doing this, okay? You get security hardened NTP operations, okay? You don't have to worry about any of the software aspects. It's all done in hardware. Extremely accurate, extremely high capacity. You protect the CPU from a denial of service attack, which in this day and age is very important because NTP and DNS are the two most popular mechanisms for denial of service. And then lastly, we monitor all of this traffic. So if you start seeing more NTP traffic than you expected, we'll send an SNMP trap and alert you to that effect. But of course, we still protect the CPU from the heavy traffic, and we process it at line speed. So it's a great combination of security and timing in one device. And this is unique to microsemi.